Right. First thing that's noticeable, the train looks, I believe, quite different. It's got a running board, all the pistons and things have been moved down, there's actual braces, there's all these boxes everywhere, everything's looking a bit different, the wheels on the tender are different, the tender's been redesigned. A lot of things have been done with not a lot of updates. And I'd like to somewhat remedy that by mostly talking about the wheels, because the wheels was, of course, the biggest pain in animation. And as you can see, I've actually got everything here reciprocating as you would see in a proper Wild Shirts valve gear. If I turn on show renderable only, you can see each individual piece doing exactly as it's intended to do. However, one thing that you might be thinking is, how did I make this? Because the last time you guys saw an episode or an update, the only proper movement thing up this end was this piston going back and forth. And so, in light of me going bloomin' ages without an update, I've decided it would be a good idea to show how everything works on this little test bench. And you can see like each and every single um theory theory that has been applied in the actual animation here has also been shown in this animation here. Like this bit where the reciprocating arm is, this bit is the bit where the reciprocating arm reads, this is the bit where maths is. Yeah, I'm not kidding. It's the exact same maths as before, the exact same formula even. I've just changed around the numbers a bit, because this is of course on a much smaller scale than the other model. Uh, in essence, I've already explained this in one of my early episodes. I don't really want to explain it again, and I don't really think I need to. But the interesting thing here, because this is just an IK rig, an IK rig is incredibly simple. It just basically figures out what the angles here should be based on the position of this and the position of this, if I'm able to, yeah, I'm able to move it. And in fact, I think 3ds Max, yeah, is usually done for animating knees to ankles, which is handy. Um, and in fact, that little diagram can help explain the spline IK solver as well. So as you can see, each individual little piece is following along the line that has been made. The line here. Here. So each one of these bones is meant to be following along this line. However, this bone, because it's so long, it can't really attach to this line here. So it's forced to attach to this line here at the end. And so it forces this one and this one to follow along the same bone. And so you press play, and everything moves in a perfectly straight line. Because essentially there's no way for this bone to connect to this point because it's too long, and it just goes, I guess. If we go here to rotation, Y rotation, you can see I've hooked up the Y rotation of this cylinder to the Y rotation of this torus here. So if I move this torus, you can see the cylinder moves as well. However, with this one, it moves twice as fast. And I did this in the leading and trailing wheels, and as well on the tender, just at a slightly different scale. And it was as simple as, if I... That's not what I'm looking for. I'm looking for this one. Rotation... There we go. It was as simple as adding a, I believe that's asterisk, and a 2 after Y rotation. And so every single time this moves, say, 5 degrees, The smaller wheel down at the bottom is moving 10. And this is done because, of course, as wheels get smaller, they cover less distance every single rotation. I don't know what that slag is about. But yeah, that's the entire thing. That's like every single animation principle that I ended up using. And again, you can see it all in action if I pull it over onto the right monitor. Here. And if I show renderable only, it looks suddenly much more pretty. Now to talk about the design of the train itself. I don't know if you remember, but the original engine I took like a basis off of was the Russian P-38 steam engine. However, unfortunately, this image seems to be the only image of the Russian Class 38 anywhere. And I believe I've already talked about this, so I won't talk about it. But only 2 were built. They were the only articulated locomotives to be built by the Soviet Railway, and they were built in 1954. So, no in-depth pictures, no schematics, no wonderful things that people can usually use when they're designing or, in fact, referencing a steam engine could be found. Absolutely nothing, which was greatly helpful. So what I decided instead was to return to familiar grounds, to put it simply. As you can see, you've still got the 4 sets of wheels here, which I don't think was ever done in the UK. But the style of running board, the boiler, the cab, everything but the tender, really. If you just ignore that, it looks quite British. Or at least that's what I believe. And it wasn't entirely intentional, but as I realised that's what was happening, I kind of played into that strength. Because being British, I grew up mostly with British steam engines because I'm autistic, and of course my hyperfixation happened to be steam. When it came to the tender, however, I looked mainly at the Union Pacific Big Boy, which, if you don't know what that is, if I can spell, I put caps lock on. How did I do that? It is another engine with 4 sets of driving wheels, and it's rather imposing, to say the least. And so I thought if I took inspiration from that rather large engine's tender, for my tender, it would make quite a bit of sense. And it does, I think. I think the tender fits. It's not done yet. I haven't added the coal, which I'm planning on doing by... There we go. This guide here, where it talks about collision and so on and so forth. And so I've already unwrapped this one piece of coal, and I've added a noise modifier, if I remember correctly. Yes, I have. And so to get with another piece of coal, I just need to tap this button, and all of a sudden it's an entirely new piece. And it's still quite low poly, and this is already unwrapped, so I don't need to worry about unwrapping it later. Then finally, the last thing to talk about, I believe, is the trees. Let it open. Let it take a while, because loading a 3D model takes time. You can see the oak tree here. I'm not really happy with the oak tree. I feel like this branch is far too long. I feel like there's not enough branches near the top. I feel like it looks more like a 4-legged nightmare creature thing rather than a tree, which isn't really what I should think I should be going for. What I am much more happy with, however, I believe I clicked on the right version, I might not have. There are 3 versions. Is... If it will load, yes it will. The elm tree, which looks very spaghetti-y, I can admit that. But all I've done with this tree is I've got a single branch here as an example, and then I just change the seed, and I get an entirely new branch. It's the exact same theory in practice as the coal that I'm going to put in the tender. And I quite like the noise modifier because it makes it look much more scraggly and random without having to put in nearly as much as the effort. And I'm going to use that on the houses that I end up making. So I've talked about the animation that I've used for the wheels here. I've talked about how these little wheels here and these little wheels here are essentially powered the exact same way, just with a little asterisk and then 2 or 4 depending on the size of the wheel. I've talked about inspirations from the tender. I've talked about how this engine looks exceptionally British. Don't think there's much else to talk about. Yeah. I will end this video off here, upload it to YouTube. Quick 10-minute recording just explaining stuff. Bye-bye.